Alright, so I wanted to do a few problems from this homework assignment that I'm leaving you guys to do tomorrow, just so you can have some examples to look back at. So these are coming straight from the sheet. I just copied them down on a sheet of paper. So I'm going to work a couple of them with you. So number one, all we're doing here is adding the matrices together. Remember that in order to add matrices, they have to have the same dimensions. And to find the dimensions, it's rows first and then columns. So for example, this matrix has two rows, and 2 columns. So this is a 2 by 2 matrix. So is this, and so is this. So they're all 2 by 2s, so we can add them together. And so the answer should also be a 2 by 2. The idea is you're just going to take the elements that are in the same spot and add them together. So like -1 plus -1 plus 0. Or 2 plus 2 plus -1. 3 plus -3 plus 2. And -1 plus 1 plus 0. And then reduce. So that makes -2, 3, 2, and 0. Okay, so adding and subtracting is very simple. We can also do problems like number 5, where you are solving an equation for x. As long as it's solving with adding and subtracting, there's not a whole lot to think about here. So for example, here I want to get x by itself, so I need to get rid of this matrix. Currently it's being subtracted. As you know, you can undo subtraction by adding. So just like you would with a regular equation, we can add this to the other side. Okay, and these will cancel. And when you add these together, it's the same thing we were doing before on number 1, where you're adding things that are in the same location. So on this side, we'll have just x by itself equals 5 plus 3 is 8. 7 plus 4 is 11. 9 plus 4 is 13. 14, 4, and 11. So x would be this matrix that is a 3 by 2. Okay. The next section of the homework talks about finding the dimensions of a matrix. And if the product can't be found, explain your answer. So number 1 here, they want us to find the dimensions of the answer. So this matrix has 3 rows, 1 column. We'd say it's a 3 by 1. This one has 1 row and 4 columns, so it's a 1 by 4. And so part of checking to make sure that you can actually do the multiplication is where you just look at the inner dimensions. There's a 1 here and a 1 here on the inside. As long as those match up, you're good to go. It'll work. And if they match up, then the answer would be the outer dimensions. So if I multiply these together, I would get a 3 by 4. Okay, and that's all they want you to find for those problems, is just figure out how big the answer would be if possible. If these numbers don't match up, it's not possible. Okay. Below that section, there are a few problems where they give you matrix A through E. And I wrote E here because I didn't realize I was going to be able to see this part, so ignore that. So on number 7, they want us to multiply A and B together. So A is a 2 by 2, and B is a 3 by 2. So if we're multiplying a 2 by 2 and a 3 by 2 together, notice that the inner dimensions there don't match up. So that means we can't actually multiply them together. This one is undefined, or no solution. What word did we say we wanted you to use? If the product cannot be found, explain your answer. If not possible, write product undefined. So the product here is undefined. Okay. Notice if I did B times A, same matrices, but we're multiplying them in a different order. Notice that this one actually works out. And that's because matrix multiplication is not commutative. The order matters. So it's not like regular multiplication. So this one is a 3 by 2. We're multiplying it by a 2 by 2. Notice that the inner dimensions there match up. The answer will be a 3 by 2 matrix. So I'm going to make myself a big 3 by 2 here. So 3 rows, 2 columns. So here's the hard part, actually multiplying them. So the idea is you look at the element that you want to find. So we're going to start here at the top. This is element 1, 1. It's in the first row. It's also in the first column. So to get it, you're going to multiply the first row and the first column together. So 0 times 1 is 0, and 2 times 3 is 6, and we're going to add those. This one is also in the first row, but it's in the second column. So we're multiplying the first row by the second column. 0 times negative 1 is 0. 2 times negative 2 is negative 4. We add those together. And this process just repeats. So second row, first column, second row, second column. Third row, first column, and third row, second column. So second row, first column. Multiply them together. Negative 2 times 1. 1 times 3. Add them. And then we go to second row, second column. So second row, second column. 2 plus negative 2. And then third row, first column. And third row, second column. And then this will reduce. We can actually add the numbers together and get 6, negative 4, 1, 0, negative 1, and 1. All right. I guess I don't really need to do every single one of these examples. 20, they ask us to find 2D, so that's 2, like the number, times matrix D, which was, oh, wait. I realize now why I put this here. Let's go back and look at 11, A times D. So A is 1, negative 1, 3, negative 2, and D is 1, 0, 0, 1. Okay, 2 by 2, 2 by 2. The inners match up. The outers are 2 by 2, so that's how big the answer is going to be. So 2 rows, 2 columns. So same method we did over here. First row by first column. Notice you'll get 1 plus 0. And then first row, second column, you'll get 0 plus negative 1. Second row, first column, 3 plus 0. And second row, second column, you'll get 0 minus 2. So that reduces to be 1, negative 1, 3, negative 2. So something kind of neat is notice that is the same as matrix A that we started with. So this matrix D is called the identity matrix because when you multiply by it, you keep the same identity. In other words, the problem doesn't change. You're going to get the same answer. Okay? So, identity matrix is a matrix where there's all ones along the diagonal and everything else is a 0. So it doesn't have to be 2 by 2. It could be a 3 by 3 or a 4 by 4, as long as there's ones going diagonally and everything else is a 0. So that's pretty useful. So 2D, 2 here is called a scalar. It's just a number. When you multiply by it, we call it a scalar for matrices, and it just scales how big the matrix is. So you're just going to multiply all of the elements by 2. So 2 times 1, 2 times 0, 2 times 0, 2 times 1. So notice that this matrix is twice as big as what we started with. All of the elements have been doubled. Alright. Moving on to the next page. There's just a bunch of multiplication on the back of that homework, and some of them can get kind of interesting. The algorithm doesn't change, it's just a bigger problem. So notice this matrix is a 3 by 2, and this matrix is a 2 by 3. The inner dimensions here match up, and the answer is going to be a 3 by 3. So let's make ourselves a big 3 by 3 here. This is element 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. So first row, first column, first row, second column, etc., etc. And the actual element number tells you what to multiply to find it. So to find element 1, 1, we multiply the first row and the first column together. So 3 times negative 3 is negative 9, and 2 times negative 2 is negative 4, and we add those. Okay, same process just continues. First row, second column, 9 plus 10. First row, third column, negative 6 minus 2. Second row, first column, second row, second column, second row, third column. And then it repeats for the third row. And then we can reduce. So 9 and 4 is 13. 19, negative 8, negative 24, 42, negative 14, negative 5, 8, and negative 3. Okay, so I hope that covers at least enough to get you through this homework assignment. Sorry I couldn't be there today. And I'll miss you guys. Have a good weekend.